Welcome back to the business track. Have you ever wondered how much data can generate more than 11 million users and how do you manage it? Our next speaker, Stefan Opariuc, is data analyst in the business intelligence team at Revolut, an engineer at heart with a passion to understand complex systems and find what makes them tick. Stefan will share how the landscape changed while the growth has been exponential for Revolut and how they tackle the challenges as a startup. Let's explore together the fintech data landscape. Stefan?
Hey guys. Hey, yeah, thanks for a really kind introduction. And yeah, I think we can go straight to it. And I'm just going to share my screen now. Hiding this one. And yeah, let's go. So the topic for today, of course, it's data. It's a whole week worth of talking about data. And today we're going to look a little bit of on the landscape, the data landscape of fintech. And there was a little bit of introduction for me, but I said I should introduce myself too. So hey, this is me. I'm Stefan. And since I know that you really like data and really accurate data, I have some numbers which are about me, more about my experience. So I have around 5 years, 4 months, and 5 days of experience. This is calculated today, so it's really accurate in time. Out of which I have been 4 years, 3 months, and 1 day a Java developer. So 79.49% of the time I have spent doing web applications with Java. I've been a community manager for 5 months and 1 day for Revolut, consisting 7.83% out of my whole experience. And finally, in the current role, it's been 1 year, 1 month, and 6 days and counting, which comprises of 20.56% out of my entire experience. So right now I know that you have like really good skills at math. And if you're going to add these things up, you probably see that's a little bit more than 100%. And I can guarantee you that the calculations are right, but we can discuss about this in private if anybody is interested. So right now, looking at the landscape, I addressed some questions in the way how I presented I described this presentation, and I said, let's go ahead with the Q&A and answer the questions that I already posed in there, so I don't have keeping you waiting for the actual answers. So the first question was how much data can more than 11 users can generate, and yeah, I wanted to be like something really big to share with you guys, but somebody already stole my thunder on Facebook and responded. So more than 11 million users can generate a lot of data, and they can and they will generate a lot of data. So the answer basically it's quite a lot. Then the next question is how can you manage it? Since you're having so many rows, so many tables, so much raw data, you need a smart way and you need scalable systems, and they have to be built by really talented people, and you need these systems to be used in order for you to leverage your data and make most out of it. Then the next question would be who should have access to it, and the answer is that everyone who should have access to it. It may sound a little bit vague, but nobody should have access to anything else rather than what they really need to have access to. This is really important in all fairness. So right now, let's talk about the actual story. And usually stories have a short version and a long version. And since right now we're at the Big Data Week, it's a really nice event, and you paid some money to see these presentations, you're lucky. Today we're going to have the short version and the full version, the longer version. So let's get ahead with the short version. So basically, this is it. This is kind of all my presentation, and the short version will be like, hey, look at this slide, and that's it. It's not really insightful. Yeah, it has these really nice graphs, but it doesn't offer details. So we go ahead and we're going to talk about the story. and we're going to talk right now about the long version. And we're going to look at each part of this graph, which comprises of all the landscape that represents the data at Revolut, and where I'm going to share some insights about them. So the initial thing that you need for a data platform is are the data sources, meaning that you need to have those databases, those sources from where you can get the data in order for you to analyze it. Because today we're going to talk more about how we leverage the data in order to have it prepared for analyzing and in bulk in big data. And at Revolut, each product or sub-product has one or more databases. And I don't know how familiar you are with Revolut, but we have basically it's a banking application, and it has different products. We have the retail application, we have the business application, we have all sorts of features like vaults, cryptocurrency, trading, and so on. So all of these features generate a lot of data whenever users or customers are actually doing something in the app. So each product has one or more DB, but it doesn't mean that these databases are comprising only with data that is generated by customers, because we have data that is also generated internally for internal applications, or we have data which is gotten from third parties. And here we can talk about back office, we can talk about the chat systems, and the third-party applications, the third party from where we get the data, for example, are the open banking. We're using TrueLayer in order to get different details from other banks in order to show into the application. And for all of these databases, the size and complexity varies from one to another. For example, we have a backbone of our application, which is an event stream application. And basically, our products are talking through this event stream. So whenever something happens in the application, different events are triggered. So you can imagine that at the end of the day, we can have like a lot of rows generated, up to millions of rows per day generated. And they need to be offset in time, and these adds complexity, but also size of the data. Also, we have other databases which are more trivial, and they can vary and they are treated differently. Again, these are PostgreSQL databases generally. We have some other in-memory databases that we're leveraging, but it's not that. It doesn't comprise actually of the data sources that we're connecting to. Now, since we have all these sources, we want them to be ready to get into our warehouse and put them to their actual value and starting to analyze them and starting to do all sorts of processes on them. So we have an ETL process which is custom, and it has been developed in-house. It's based on YAML configurations, and it basically does what generally an ETL process is doing. So it describes the connection, describes the name of the model that is replicated, fields, private keys, whatever. It can connect to multiple databases, and it has also some built-in transformations that you can leverage in order to get the data and load it in the warehouse in a different way. It connects securely. This is done through a proxy, which authenticates the ETL process. Is done reliably, and it is constantly monitored. And everything is logged and it's traceable. Each time we know that what data has been fetched and has been introduced into the data warehouse. Also, one key aspect of the ETL framework is that it allows to have quality checks. And here they represent quality checks between the warehouse itself and the data sources. But also we can define quality checks inside the warehouse itself. And as I said, the process is highly traceable. Each time we know what has been fetched, what has been dumped. We know everything at each point. Also, the configurations provide insightful metadata, so we know who is owning the model, who is the maintainer of the model, which are the primary keys. We have the documentation for it that we're leveraging in order to know what data we actually have into the warehouse. The database inside, which represents our warehouse, it's a Nexasol database, and it's a columnar database. It's really fast. It holds tens of terabytes worth of data, and is constantly monitored in terms of performance, but also of space. The availability is extremely high because there are a lot of clients, which we're going to talk about in the next slides, and it needs to be really available for querying. And it's optimized for analyzing very, very big data sets. And this is something which we benefit a lot when we're doing these querying in the database. Now, we have the sources, we have the ETLing, but generally sources represent databases, and we needed another way how we can get information into our warehouse. And one thing which we needed was to sync sheets into tables. Usually we have people who aren't that accustomed with databases, and they are doing things in Excel, in Google Sheets. And we needed a way to import the data also into the warehouse to do all sorts of things, all sorts of analysis, or digest the data in some other applications. We also pull data from APIs. We have some fetchers. We use them to benchmark our products, for example, to see how the performance marketing is doing, to see how the application is doing in App Annie, or so all sorts of different things, Facebook ads or whatever. And we're fetching this data in order to leverage it again in our warehouse. And we retrieve utilitarian information. The best example that I can have here is we are pulling rates in order for analysis, in order to transform different amounts in different currencies. So this is kind of the best example here. Now, we have the sources, we have the warehouse, and let's talk right now about who are the clients of the warehouse. And this is pretty interesting because we have clients that are consuming and digesting the data, but we also have clients that are taking the data and pushing back data into the warehouse. And we're going to go in turns. Probably you already recognize some of the icons that I put in here. And the first one would be Airflow, which will do basically scheduling jobs. This sounds quite trivial, but this is what Airflow actually does. And how we're using it in our warehouse is to create all sorts of pipelines, data pipelines, and we're processing data for reconciling different data, for calculating P&Ls, for running fin crime models, or all sorts of things. We're also running on it different aggregations. So we're getting bulk data, and we try to create new models which analyze these data and creates all sorts of aggregations in cubes. We create new models inside the warehouse. For example, we can have really raw models which are really hard to digest or to query or to make sense actually out of them. And we're building on top of them new models that are used in analysis, and it's way easier to interact with them. And one thing of Airflow is that it doesn't actually interact only with a warehouse. It can combine also different sources in here, and we can produce a hybrid output. Then we have Metabase. Metabase basically is our dashboarding tool. And it's an enhanced version of Metabase. So in order for us to scale, we needed to make a little bit of tweaks to it. Since it has also an open source version, we were able to get the code and do our doing in there. And we kind of tailored it around our needs. So one thing which we did here was to have cached versions of really heavy queries, because those ones were clogging the performance of the database, but also on the way how the things were loaded in Metabase. And also we needed a smarter way how to do data accesses. So we needed different levels of accesses on different parts of Metabase. So we need to see which will be the database accesses through Metabase, which would be the collections, cards, dashboard, and so on. And this is extremely and highly used tool inside Revolut. Basically, anybody can have access to it, but again, with a lot of control on the accesses. And we've reached over 1,000 distinct users that are running in the dashboard inside Revolut. We have over 75,000 cards that we're using. Is like queries that are running on the database is underlying, and over 5,000 dashboards that we have created in here. And since we have really good access management in Metabase, we were able to expose some of the dashboards to third parties in a really controlled way. For example, we have investors which want to look at the way how Revolut is performing, and we've used this one. We gave them really limited access to see data about how we're doing. And also, one of the most interesting things that happened with external parties was our collaboration with the UK government. Since we're in these really interesting times here, we have a collaboration with them. We're sending the data in the way how the spending behavior has been changing in regards with different events. And this was really interesting, and we could leverage actually Metabase with these control accesses in order to get this data to them. Then we have so many other Python applications and also some Java ones, which are getting the data and are creating either internal tools or are doing different exchanges, or they are controlling P&Ls or whatever. So basically, they are relying on the data in the warehouse to do it. Also we have different database clients connecting directly in here. Cool. So this is the full picture in here. And if you were attentive until so far, there are two things which are missing. So these are the core things about our platform, and this is basically our data product. This is how we see it. We see data and the way how we're using it as a product in itself, with different clients that are used internally. And as you can see, I told you some numbers of how many queries are running. So now our product has around 1 million, almost 1 million queries executed daily. We're ETLing around 20,000 jobs batches per day. So a lot of data is put in there, and that's all done only by the ETL framework, not other sources. And yeah, Exasol is really cool and is acting really nicely when you're querying and doing analysis. When you have so many people that can do queries inside it, and when you have also clients that can actually connect directly to it through Datagrip or Exaplus or whatever, then it can be quite strained and can get a lot of pressure. So we needed to address this thing, and this guy appeared into the picture. We have a really nice watchdog, which has one job. Basically, this is one of a reference to a movie, and I'm going to spoil it. Which one is for you? He's the hero that the database actually needs, but he's not the one that it deserves. And what this dog does, it stops resource-heavy and unoptimized query from being actually executed on the database, because these ones could potentially get a lot of resources and could clog the actually execution on the database. And it's really interesting because it's a smart dog, and not only does it stops your query, but it also notifies you that it has been stopped, so you're not left hanging in there. And it also offers details about what went south with your query. So since we have accesses to the way how the query has been executed, we're profiling it, and we're going to tell you, hey guy, you wrote this query and it's bad, and this is how you can fix it. And if you are unable to fix it, then please chat with these guys and they can help you. So if you're not a data person, you're still notified of how you can actually make it a little better, or whom you can ask for help. This has been quite a good savior of our database so far. Then we needed another way to interact with the ETL framework. So this framework being a YAML file configuration. It's based on YAML file configurations. It was really technical to actually work with it and do stuff inside it. So we designed the data portal. And this is a web application which basically lets you interact with the ETL pipelines. And it offers you the possibility to create different tables from different data sources, and also to add other data sources that are not there. But also it gives you access to add, delete, or edit different fields of already existing configurations, which is really cool because you don't actually have to learn all sorts about version control and how to change YAMLs, how to test, and so on and so on. Basically, this is done in a really nice and with a web application. And also we have these business people who are not really technical and they want different sheets to be imported or different data sources to be added. And they don't have, like in their team, they don't have the engineers. And in order to make it easier for them, we created this portal, and it's really helpful so far. We've optimized the way how fast we digest the data. And also it offers the possibility to add documentation on the tables, on the columns, on what's in there. And this helps us a lot because we have a better overview of what's inside there. And not only do the engineers have to do this, but also the business people can actually get in there and add these documentations that we really need. So this was the long version. And this is kind of the end of the long version and the short version. And what's left for me right now is to thank you. And I timed it, and we'll have around 9 or 10 minutes to actually get some questions.
Thank you, Stefan. Indeed, we have some time for questions. I will check the chat now, and I have a question from Claudia. She is asking if your infrastructure is built on premises or if you use resources from a public cloud provider.
It's in cloud. It's in Google Cloud.
Okay, and there is another question. Tell us what kind of impact had for Revolut this kind of model that you are using, and of course, which are the benefits for the business?
Okay, so I'm going to tell one of the things which is really interesting about Revolut is that it has a lot of data since it has been used. And the growth of usage has been exponential, and that means that our data, if we're looking in raw size, has grown also exponentially. And right now, it's easier for us to look inside it and take out from there different patterns, both in spending, user behavior in the application, and we can use these ones, like in the example with the UK government. But also we are using them in order to create media reports. Since we have these behavior patterns, we can then check with the media and do sort of case of studies of how things are changing. And also we can do marketing, really smart marketing around this one, because the data in there provides insightful information. How the model helps this is that we have recurring questions about our data. And since we see the pattern of what is needed from there, we can create new models, we can create new dashboards, which can be used and applied in different situations. For example, our comms guys, when they want to issue a new report or they want to talk with the media, it's easier for us to calculate all sorts of metrics for different countries. And you have to do it only once, and then you're just going to need to apply the filter on what market you want to build a report on.
So you say that it's more important to know how to analyze actually the data than to manage it, or they are have the same kind of importance?
I think that if you don't know how to manage your data, you cannot analyze it. If it's a mess in there, you can write reports that can be false if you don't know what and how to digest the data and do stuff with it. So even if you're getting the amounts and you're doing some approximation, or you're transforming it in a really weird way, then at the end you can have a false report on, let's say, spendings. And this is just some small thing. I was reading an article a few days ago about the fact that they were rounding some amounts, and in the end they had a loss in business for around 2 million a year or something like this. And it was just a simple rounding. Also, there was this scandal in the UK that they just lost some people who were actually they were having COVID virus. They were tested positive, and they didn't know about them because they exceeded some space when they were calculating it. So I think you should know how to manage your data, both on a lower technical level, but also on a higher level of understanding what's that data about, in order to have meaningful analysis and correct.
Thank you. We have a few minutes, so I want to go back right at the first of your slide of the presentation. And please explain us your calculation. It was a very intriguing part. How you arrived at that process?
Yeah, so basically, this is at some point I was working as an engineer, and I really loved Revolut back then, and I still do. And I wanted to be a part of the movement, and I had my engineering role, and I also wanted to build a community here in Romania. And basically, I was working two jobs in the same time, which was both interesting and quite exhaustive. The landscape, the way how we're doing things at Revolut is quite fast paced, and it needed a little bit of time, or a little bit more of my time, to actually build the community, have all sorts of events, talk about the product, and build the community itself. And yeah, I basically have done it in parallel. Now I settled. I am doing data analysis, and yeah, I got to this percentage in my experience, percentages in my experience.
So actually you gave us all a trick how we can gain experience, like 4 years of experience only in 2 years. So it's good to know. Thank you.
Yeah. Thanks.
Thank you, Stefan, and thank you all for joining. We will close this session now, and we invite you to join our next one. Please don't forget that each session is broadcasted independently, so make sure you check the live session tab for the following one. Thank you again.
Bye, guys.